here refer to the shear stress. Okay, shear stress tau. Okay, shear stress tau. So why this shear stress? Where it's come from? This shear stress. So this shear stress develop in the shaft when we twist. When we twist. Okay, whether we fix one end or both ends, it doesn't matter. So when the shaft is twisted, so the shear stress we develop in this shaft. And then the shaft we discuss here is refer to the circular shaft, not rectangular or square shaft. So round shaft, round shaft. That is the first thing, how to calculate or how to determine the level of stress of the shaft. The second thing is how to determine when we twist this shaft, so the shaft will deform okay, until let's say a certain level. If we increase the torsion, so this body or this shaft will deform. So how to measure the deformation of the shaft? So we can measure the deformation of the shaft is based on the what we call as angle of twist. Angle of twist. Before this, for the rod and so on, when we pull or push, so we can measure the deformation by the elongation or contraction. Delta equal to PL over AE. So that one is for axial force. So now we have the torsion. The torsion. So how to measure? We refer to the what is we call as angle of twist. So angle of twist equal to theta. Theta, the formula equal to TL over JG. T is the torque, L is the length, J is a polar moment of inertia, and G is modulus of rigidity. Okay, still uh, Hanif. Hanif for that join. Okay, so that what we discussed before this, and then also we discussed about if the shaft is solid. Solid mean that the shaft is not hollow, not hollow. So we can simplify our formula to determine the shear stress, maximum shear stress. So maximum shear stress equal to 2t divided by pi r cube, pi r cube. So actually, it doesn't matter. You can use the general formula. General formula for the tau equal to PR over J. It doesn't matter. Is it R is maximum or R is minimum? It doesn't matter. But for the practice, normally in some books they use R equal to C when R is the maximum. R is the maximum means that R equal to the outer layer of the circular shaft or outer diameter or outer radius of the circular shaft. So that we discussed about these two things about the shear stress and also the angle of twist. And then we discussed also about the sign convention, positive and negative torque. Positive and negative torque, because this is very important. Okay, if the torque is not the same direction, so direction here refer to the clockwise or anti-clockwise. So how to determine the positive and negative is based on sign convention. So you have to use your right hand, what we call as right hand rule. Right hand rule. So your fingers will show the direction of the positive torque, and your thumb is refer to this direction of the axis. Refer the axis. Okay. Kita masih lagi ada yang nak join ni. Okay, Ilyas. Okay, so it means that if we cut here, just show you point either. If you want to cut here, so if you cut here, so we have two parts. The first part is here, and the second part is here. So it doesn't matter which part you want to refer to. It's okay, no problem. So if you choose this part, so this is the diagram looks like, and this is your position of your hand, right hand, your right hand. If you choose this section, so this is position of your right hand. So based on this, we know the direction of the positive torque or negative torque. Huh? So masih lagi ada yang mau join ini? Tak ada. Tak ada. Okay. This is sign convention, and then we just go through this example. Okay, so this example, if we have a shaft like this, okay, we have a shaft like this, okay, A, B, C, and D. So we have to determine the torque, the torque, the neck torque or internal torque here for each section. The section here refer to section AB, section BC, and section CD. Yeah? Section CD. So this is the net torque. So the blue color here refer to the external torque. External torque. So in our calculation, we refer to the internal torque. So how to determine the internal torque? You have to cut in between. Let's say for the section AB, you have to cut between A and B. For BC is between B and C, and for CD is between C and D. Yeah? Okay. So that we have already discussed last week. Yeah, last week. Okay. So this is the positive and negative torque. Okay, and then so I hope you understand this one. So everybody knows how to determine the net torque. Okay. Before I proceed to the before we proceed to the next example, I hope everybody knows how to determine this net torque. Huh? Okay, semua boleh faham? Huh? Masih ada lagi yang mau join ke? Samsul. Semua boleh faham? Everybody knows how to determine the net torque. Please give me your response, please. Khalid Kormain, boleh faham? Khalid, where are you, Khalid?
Saya.
Huh? Okay. Do you understand about the how to determine the net torque between AB, BC, and CD? Why?
Kurang faham lah, doktor.
Which part?
Macam mana kita determine dia positif atau negatif? Macam
okay. Positive negative is based on right hand rule, based on this one, right hand rule, Okay, this right hand rule. So let's say this is the shaft. I just repeat, because if you cannot understand how to determine the net torque, you cannot proceed. Okay, you cannot proceed to determine the shear stress and also the angle of twist later. So make sure you understand. Okay. So let's say this is the shaft. This is the shaft. Okay. So and then when we cut here, Okay, we cut here. So we have two parts. We have left hand side and right hand side. So you can choose any one of them. This doesn't matter. You can choose the right one or left one. This is okay. If you choose the right one, right hand side, so this is the diagram like this. Okay. And then of course when you cut here, this is the axis. This is the axis. Huh? So you just put your hand like this and your thumb, this is your thumb, the direction of this axis, and your fingers here refer to the positive torque. This is the positive torque if we refer to this section. If we refer to this section, okay, so it's become opposite direction. So when it cut here, so this is the axis. This is the axis. We cannot refer to this axis so because we cut here. Okay. this one is referred to this axis. Okay, so when we cut here, this is the axis for this plane, for this plane. So, and then this is your right hand rule, or your right hand, and the positive torque equal to this one. And then, of course, if you compare this part and this part, the direction of the torque must be opposite direction. Okay, okay,
Okay, Doctor. Faham.
okay, Khalid, ya.
Alright.
Okay.
Yes, sir.
Uh, Emiliana, do you understand? Emiliana, where are you? Emiliana, Emiliana tak ada hari ni. Amzar, Amzar,
Faham Doktor, faham.
okay, okay, yeah.
Ya Doktor.
Okay, yeah. So this is how we, and then we go to the example number 1 last week. So in this case, we want to determine the shear stress, maximum shear stress. So what I mentioned before this, how when we have we want to determine the shear stress. Okay, we can simplify our formula. We can simplify our formula instead of use the general formula. General formula equal to TR over J. So if we want to determine the maximum and the body is solid, solid means that there is no hole inside and inside the body. Okay, there is no hole, what we call as a tube or hollow. So we can simplify that formula instead of TR over J. So the formula become 2T divided by pi R cube. Okay, so I think this one. Okay, so this is tau maximum TR over J or TC over J. So C or R is the same. Okay, as I mentioned before, there's some books that you see. C refer to the when R is the maximum. So if you want to put R here, it doesn't matter. Okay, doesn't matter. So and J is equal to J is the polar moment of inertia. So this J it depend on the cross section, like second moment of area what we discussed before this. So it depend on this area. So J is the polar moment of inertia. So this one it depend on the cross sectional. So pi over 2 r power of 4, and when you substitute this J to this formula, and then you can simplify the formula T maximum equal to 2T divided by pi R cube or pi C cube. Okay, so based on that, we can determine the tau maximum. Just put all the information in this formula. Okay, tau maximum equal to 87.3 megapascal. Okay. Okay, this is just repetition. I just repeat what we have done last week. And also for this one, this is for hollow shaft. In this case, you want to determine the maximum shear stress caused by the torque of equal to 1 kilonewton. But in this case, we cannot simplify the formula because we have two different radius or two different diameter. So we just follow the a general formula. So this is the solution that we discussed before this. Make sure here, okay, make sure here, okay, G equal to pi over pi over 2 R power of 4 or C power of 4 for the external or outer radius minus C1. C1 is the inner radius. So make sure, so C2 power of 4 minus C1 power of 4 not, it's not equal to C2 minus C1 power of 4. No, that one is different. Okay, and then based on that, we can calculate the tau max. Tau max. Okay, so today we proceed to the next example. This example and the rest is maybe more complicated, but I think if you know how to determine the internet torque, the net torque, So you have no problem. So in this case, we have the shaft. We have the shaft like this. Okay, this is the shaft, and then here we have the disc. We have the disc, and the shaft is supported by two bearing here or to support. Okay, bearing here. So bearing here. So what is the function of the bearing? You can explain to me what is the function of the bearing? Okay, Suhail. Where is Suhail?
Saya doktor.
Yes. What is the function of bearing?
Support shaft.
Support and then
Rotate.
rotate. Okay, to support and to make it shaft rotate freely. Yeah. Okay, rotate freely. So sometimes that there is no friction. There is no friction. Okay. No friction between the shaft and the bearing. So that is the function of the bearing. Okay, so in this case, we want to determine the shear stress developed at the point A. So the point A is the outer layer of the shaft. This is the cross section of the shaft, and the shear stress at point B. So we have how to determine the shear stress at point A and point B. Okay, dia nak masuk ni. Okay, Hafiz. Okay. Okay, so you want to determine the level of stress at point A and at point B. Yeah? Okay, this is cross section for the shaft. For the shaft. So before that, how to determine the shear stress? Shear stress equal to TR over J. TR over J. So R we refer to the position of point A and point B, and J of course in this case equal to pi over 2 R power of 4 or pi or equal to pi over 32 d power of 4. D power of 4, it doesn't matter which one you want to use, whether radius or diameter is okay. So this shaft, the torque here equal to 4250, here is 3000, here is 1250. So we want to determine the shear stress at plane or at section AA. So this is the section AA. So we cut here. So when we cut here, what is the internal torque here? Okay, what is the answer? What is the internal torque for the section AA? Okay, the section AA. Okay, what is the internal torque?
1250.
1250. So when you cut here, you have a choice. If you want to take this section, you want to analyze this section, so automatically you know that here equal to 1250. So 1250 here, okay, this is external torque. So internal torque is at a section AA. So at section AA, the internal torque equal to the same. Same is 1250. 1250. Why? Because this is must be opposite direction. Okay, opposite direction. Why? Because this is based on Newton third law. Newton third law. So the net torque here is positive or negative. Positive or negative? Net torque here. Positive or negative? You can apply your right hand rule. Positive. Huh?
Negative.
Negative, huh? The answer is negative. Why negative? Because when you cut here, okay, your right, you can see my hand, right hand. You can see my hand.
Yes, sir.
Okay, this is your right hand, and this your thumb must be to this same direction as the axis, and this is the positive moment. Okay, but in this case, this is clockwise. Here must be anti-clockwise. So anti-clockwise here is positive, is clockwise. So because this is anti-clockwise, so torque equal to positive torque. The same thing here. You can use the same process on the section, and you can see that. So let's say this one equal to 4250. This is anti-clockwise. Here is clockwise. Okay, so 4250 minus 3000 equal to 1250. So 1250, which direction? Here. Which direction? Okay, kalau kita ambil this section, which direction? Is it clockwise or anti-clockwise? When you cut here.
Clockwise.
Clockwise, clockwise. So clockwise, your right hand rule like this. So direction is opposite direction for opposite direction with your, if you compare to this your hand. So that's why is neck torque is negative. The same thing. Okay, if you choose this section, you can get that torque equal to 1250 and negative. If you refer to the section, you can get the same answer, 1250 and negative. So that's why it doesn't matter which part you refer to. Okay, you analyze, so the answer is the same. Okay, so how to analyze? So how to analyze? Okay, so of course we have to draw the free body diagram. Let's say in this case we choose the left segment or left section. Okay, so it's like this. Okay, this is the torque. This is the torque. It's clockwise. Okay, so clockwise plus this one equal to 4250. So based on that, total total moments. Actually, this is not correct. So actually, this is not total moment. This is total torque. Sorry, this is typo error. So typo error here. Please make a correction. So this is not moment. This is torque. Total torque equal to 0. So we have 4250 minus 300 minus 3000 minus t equal to 0. So t equal to 1250. So why we choose here equal to positive and here is negative, here is negative. So again, this is right hand rule. So this is your hand, and this is your right hand, because this is the axis. Okay, this is an axis. So your right hand rule. So this your finger refer to the positive torque, the positive torque. Okay, if the direction is opposite to this your fingers, so automatically the value become negative. Okay. Okay, this one. Ada siapa lagi tak faham? Afir, Danish. Afir, Danish.
Faham, Dr. Faham.
Faham? Okay. Okay. So that one is based on this section. Okay, this FVD. And then the second, polar moment of inertia of the shaft equal to J equal to pi over 2, R power of 4. Okay, so you can get this one. Okay, and then after that, point in for the point A, the C equal to R 75 milliliter. You just put on this formula, substitute equal to TR over J or TC over J. So everything is here equal to 1250, and then this is the R or C. So this is polar moment of inertia. Okay. Sorry. Pointer. Apa dia tak function? Point. Okay. So this is the T. This is R or C. Okay, and then this is the J. So the shear stress at point A equal to 189 megapascal. Okay, that is the first part to determine the level of stress at point A. So the next question is to determine what is the stress at point B. So this is location at point B. So the distance from the center equal to 15 millimeter. Okay, so the same thing. Okay, we can determine the shear stress at point B, shear stress at point B equal to T, net torque at the section equal to 1250, and the distance here equal to 15. So divide by the J. Okay, divide by J. Okay, I just to know whether you understand why we use the same J. Why we use the same J here? Why? Why? Victoria. Victoria. Why? J equal to the same J as here. Why? Victoria, where are you? Hello? Hello? Victoria tak datang ini ya? Zare? Zare? Zare ada tak? Zare tak ada ya? Zare tak ada, saya tanda tak attend lagi ni. Zare? Tadi saya tengok ada tadi. Christina?
Yes, Doctor.
Why? Why J here is the same? Why?
Don't know, sir.
Why? But
I don't know, sir.
so as I mentioned before, J it depends on the cross section. So at the same point, at the same plane or the same cross section, J is the same. Why? Because they have the same cross section. J depend on the cross section. Okay, J it depend on the cross section. Okay, so that's why we use the same J here. So the difference here is only C or R. So for the point A, R equal to 75 because the distance from the center equal to 75. And for point B, R equal to 15. Okay, that is the difference between point A and point B. And if you you refer to this result, okay, tau A and tau B, of course, theta A is higher compared to tau B. Why? Because, okay, so from this formula, T is the same, J is the same. So to make it different only because of the location, and the location refer to the C or R. Okay, so this is the solution of this example. Do you have any question before we proceed to the next example? Hazira? Hazira? Where are you? Tak ada juga Kapil? Kapil?
Yes, sir.
You understand?
Yes, sir.
Okay, good. So we proceed the next example. Proceed the next example. So this one. Okay, so this one we have three gears, or we call as this here. Okay, under normal operation condition, the electric motor, this is the electric motor, A is the electric motor. Okay, the electric motor exert a torque of 2.4 kilonewton. 2.4 kilonewton. It means that you mentioned here. So this motor will supply the torque about 2.4 kilonewton at A. So knowing that each shaft is solid, so the shaft here from point A to point E is a solid. Okay, so determine the maximum shear stress. What is the maximum shear stress in shaft AB? So between A and B, between B and C, and also C and D. C and D. So what is the maximum shear stress? So the maximum shear stress, the formula is Tc over J or Tr over J, or you can simplify to tau equal to 2T divided by pi r cube. So that is the simplified formula. So as I mentioned, you can use the general formula equal to Tr over J. It doesn't matter. Okay, so the first thing here, you have to know the net torque in each section. I just to make sure you understand what is the net torque between A and B. What is the net torque between A and B? Abdul Rahman? Abdul Rahman Abdul Salam ya? Abdul Rahman? Abdul Rahman? Tak ada? Tak ada? Abdul Rahman? Tak ada? Siti Hajar? Between A and B, what is the net torque? Siti Hajar? Tak ada UI? Semua orang tak ada ke ni? Hello? Hello? Semua tak ada? Semua tak ada, saya stop iklan ni.
Ada doktor.
Ada doktor.
Ada, doktor.
Ni diorang duk je ni.
Ha?
Diorang type je tu jawapan dia.
Oh, saya tak nampak sebab saya gunakan ini.
Oh.
Kalau you type, I cannot see because I use apa ni presentation ni, saya tak boleh nampak. Okay, tak apalah. Okay, between A and B. Between A and B. So what is the torque? I just to make sure you understand how to determine the net torque. Between A and B equal to
2.4, sir.
2.4 doktor.
2.4 kilonewton. 2.4 kilonewton. So which direction? Clockwise or anti-clockwise? Clockwise or anti-clockwise? The direction of the torque. Clockwise or
Anti-clockwise.
Anti-clockwise, sir. Anti-clockwise.
Anti-clockwise.
Are you sure? Anti-clockwise. What is the direction of the motor?
Clockwise.
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 Clockwise, huh?
Hmm.
Okay, clockwise, huh? So the torque supplied by the motor is clockwise. So between A and B is 2.4 kilonewton. Between B and C, what is the internet net torque? Between B and C,
1.2.
1.2.
1.2. C and D,
0.4.
0.4. Okay, yes.
Yes.
Correct. D and C, D and E,
0.
what is the net torque between point D and point E?
0.
Huh?
0.
Why 0? Huh? D and E 0? Sure. Why the torque net torque between point D and point E is 0? Why? The answer is? The answer is 0. Okay, the answer is 0. Between D and E is 0. The shaft D and E only just follow the shaft before that. Okay, here is the torque equal to 0. Just follow. Just follow. Except if there is a friction at point E. Okay, if they have a friction at point E, so the torque here, the shaft, within the shaft, it will develop the torque. But we assume that there is no friction here, so the torque here equal to 0. Okay, so that is a very, very important information that you have to know. okay, the net torque in each section. Section here, I refer to the AB, BC, and CD and DE. That is the section. So based on that, so I think it's quite simple, very simple, very easy for us to calculate the tau for section AB, BC, and CD. Okay. Okay. For example, this is we refer to the section AB. So section AB before this, we know that tau AB equal to 2.4. Okay, and then this is the C. The C equal to half D. Okay, and then we can apply this formula. The formula we just simplify, as I mentioned before this. Why we can simplify? Because we want to determine the tau maximum. We want tau maximum, and then this shaft is solid. So that's why. So we can simplify this formula equal to 2t, t equal to 2.4, and pi. And this is the R. This is for the R. Okay, so based on that, we can determine this is the tau or the shear force between A and B. Yeah? So between B and C, here B and C, so the net torque here equal to 1.2 as we discussed before this. So this is diameter or radius for shaft BC. And then the same thing, we just simplify in the formula and then put all the information in this formula. So the tau equal to 62.8 megapascal. Okay, that is for BC. Yeah? And for CD, same thing. CD, the net torque equal to 0.4. Okay, and then this is the radius. And then after that, you can determine the tau CD equal to 2t divided by this J. Okay, J. So the answer is 20.9 megapascal. So that is the level of stress in each section. And the tau for the section DE equal to 0. Why 0? Because the torque, the net torque between D and E is 0. Okay. Any question before we proceed to next example? Okay. Huh? Okay. Boleh? You can proceed.
Boleh ke?
Okay.
Boleh, boleh.
Okay, proceed to next example. Okay, next example. So in this case, we have rod A, B, and B, C like this. We have two different diameter. Okay, the allowable stress equal to 104 megapascal. When we apply the torque at the top of this shaft or this rod, the maximum stress equal to 104 megapascal. So for the top part refer to the section AB equal to 38 millimeter, and BC is 46. 46. Okay, so 104 for top and 55 for the bottom part. Okay, so the question is, what is the largest torque that can be applied at A? At A. What is the maximum torque that can be applied to make sure both section A, B, and B, C are safe? Okay, so in this case we have to analyze one by one or section by section. Section A, B, and section B, C. Okay. Okay. First. Because of the T is tau here equal to maximum, so we can simplify this formula as before. Okay, you can simplify. Okay, so you can apply this formula. This is general formula, and this is the simplified formula. Simplified formula. It doesn't matter which one you can use. Okay, let's say for the shaft AB, for the top part. Okay, tau maximum equal to 104 here is mentioned. Okay, C equal to 38 divided by 2 equal to 19. So based on that, we can calculate the torque, the torque here, maximum torque that can apply to this section equal to, okay, you just put all the information in this formula, pi over 2. Okay, so this is the torque. This is the maximum torque that can be applied at the A. And the same thing you can analyze for the section BC. Okay, tau maximum equal to 55 and diameter here equal to 46 divided by 2 is 23, sorry, 23. And then based on the formula we have the maximum torque for the section BC equal to 105 kilonewton. So what is the maximum torque that may be applied at A? So we have to answer here, this one and this one. So the answer is which one? Is it 1120 or 105?
1.05.
1.05.
1.05.
The answer is 1.05. Okay, we choose the smaller torque. Okay, the smaller torque to make sure both section BC and AB are safe. Okay, so that is this solution that we can solve for this problem. Okay, can we proceed to the next one? The last one, I think. Okay, the last one. Okay, so this one example, this example 7 actually, the previous example, we just concentrate on the tau, how to determine the shear stress. Now for the example 7 is we start to use the what we call as angle of twist. Okay, theta is angle of twist. So in this example, we have the ship. So this is the ship. Okay, ship just start to drill for the oil on the ocean floor. This is we call as ocean floor. This is ocean floor, or sometimes we refer to the we call it a seabed as seabed or ocean floor. And the depth equal to 1,500 meters or equal to 1.5 kilometer. It's very it's quite a depth. It's quite depth. You just imagine the pipe. The length of the pipe equal to 1.5 kilometer. It's quite long. So this mention here is knowing that the top of the 200 millimeter diameter of steel drill. So this steel drill and the diameter equal to 200 millimeter drill pipe, and the modulus of rigidity G equal to 77 gigapascal, rotate through 2 complete revolution before the drill bit at B start to operate. So what is the maximum shear stress in this pipe? Do you understand what is the problem in this case? Okay, let's say this is the pipe. Okay, let's say this is the drill pipe. This drill pipe, and the length here equal to 1.5 kilometer. 1.5 kilometer. If you rotate the top part of this pipe 2 revolution, and 2 revolution means that 720 degree at the top. So the bottom part of the drill just to rotate. You faham? Kalau saya pusing at the top is 2 pusingan, so yang kat bawah ni baru mula nak pusing. So maknanya this pipe is twisted. Okay, so you just imagine this is the length is very short, so of course we cannot when we rotate at the top, so automatically at the bottom must be rotate at the same time. But if the length is very long, okay, 1.5 kilometer, okay, if you rotate the top part, the bottom part just to rotate. The top part you rotate 2 pusingan, 720 degree, and the bottom part just to rotate. Okay, so what is the maximum shear stress? What is the maximum shear stress? So in this case, we have to apply both of them. Okay, both formula we have. We have theta equal to TL over JG. So this is angle of twist. So we can rearrange this formula. Okay, so T equal to J G theta over L. And then also we have this formula, tau equal to TC over J. And then we can combine, because this T equal to here T. We just put all this, just put T here to here again. And then this is equal to the formula we have. Okay, and then based on that, we just put all the information, the data we have. So at the end, we can determine the tau. So tau equal to 64.5 megapascal. That is the maximum shear stress in for the drill pipe. Okay. Any question? Any question so far before I'm stopped? Okay, and then we continue on the Wednesday. Or you want to proceed the next example? You want to proceed or stop here?
Stop here.
Stop here. I know the answer.
Stop here, doktor.
I know the answer. I already know
Teruskan
the
doktor, teruskan.
Ada je yang tu.
Teruskan doktor, teruskan.
Habiskan terus. Habiskan terus, doktor.
Habiskan terus. Habiskan terus.
Dok geram ni.
Datang saya
Ni,
tak
dok
jumpa,
geram ni.
Hah? Ada yang dah nak habis tu.
Anik semangat doktor.
Datang nak habis betul.
Bukan Maxis bagi free je.
Messi dah bagi free ada guna benda lain lah.
Strategi je.
Astagfirullah.
Cina nak proceed or nak stop? I don't mind. I'm ready.
Doktor, nak tanya. Alah.
Okay, tanya.
Yang example 5 tu.
Siapa 5?
Yang tadi. Yang ni.
Okay, this one.
Yang ni kita punya radius tu dia tak cube kan sebab dia dah maksimum dekat formula tu.
This one.
Cube. Tapi dekat bawah yang doktor tekan next.
Kat mana?
Ini dia. Dia tak cube kan. Dia punya C tu.
Okay, this one. Okay, dia missing. Tapi kalau
missing
missing ni.
Bukan sebab dia max.
Sekejap. Dia max 23. Okay, sorry. Part over 2. Max. So, sepatutnya ada cube kat sini kan?
Betul.
Cuba dia ni calculation. I pun tak pasal ni. Dia tekan calculator.
Jawapan dia ada cube, doktor. Ada cube.
Ada cube kan? Dia missing cube kan? Missing cube
Betul.
Missing kan? Tapi jawapan dia betul kan?
Betul.
Okay, jawapan dia betul. Dia tertinggal ni. Typo. Okay?
Boleh.
Okay, any question, any more question? And then, I just send the assignment. So different group have different question, but maybe some of the question is the same. The same, because that's combination. But roughly, different group have different question. So try your best to answer that question. And then make sure you discuss with your friend, and then you can make sure you understand. If you have any problem, you just contact me. You just contact me how to solve the problem. So at the end, you have to submit only one answer. What I mean is for the group project, only one. It's not everybody submit.